Hello, welcome to 1.3 Polynomials and Factoring. Again, this is a review topic. In fact, most of Chapter 1 is review. So I'm going to go rather quickly through it. You can always pause to take some time to write the notes down. All the notes are available. If you click under the post lesson notes, they're available for you to print out. In a living color too. Look at it. Nice blue, the black. Okay, sometimes they even use a red and an orange. Okay, so polynomials. Let's talk about this first. Now let's start at the constant. A constant is a number such as 5 or 27. A variable is like a letter or something, a symbol that represents a value. A term would be a constant, so a constant could be a term. A variable like x can be a term, and x is the most common variable we use. Or the product of a constant and a variable. The degree of a term would be the sum of the exponents on the variables, not the constants, the variables of the term. A monomial is a single term. A binomial is the sum or difference of two terms. A trinomial is the sum or difference of three terms. And a polynomial is, anyway, the sum or difference of many terms. I was going to make a joke, but I think it would fall flat. So if you have many terms, like 4 or 5, whatever terms you just call it a polynomial. The degree of a polynomial is the largest of the degrees of the individual terms. So I'm going to give you an example, like a 2x squared would be an example of a term. We have 3x squared y cubed. The degree for this would be the sum of these powers, which is 5. So like x is a monomial, 2x plus 3 is a binomial, 3x squared minus 5x plus 4, 3 terms trinomial. Now the degree of the polynomial, if you have 3x squared minus 5x plus 4, the degree is 2. Because the highest degree on any term, this is a term, that's a term, that's a term, is 2. Okay, polynomials of a single variable, what we're going to use mostly. So polynomial in the variable of x, variable x of degree n can be written in the form a sub n x to the n plus a sub n minus 1, x to the n minus 1 plus dot 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 plus a1x plus a sub 0. Where a sub n minus 1 through a1, a0 are numbers, just numbers, a sub n is not equal to 0, and n is a positive integer. This form is called descending order. You're going from a high degree to low degree because the powers descend from left to right. The leading coefficient of this polynomial is a sub n. So whatever the coefficient, it could be 1 of your highest power. Whatever the coefficient is your leading coefficient. You can add two polynomials by combining like terms. So now we're going to add or subtract the following. 4x cubed minus 9x squared plus 1 plus negative 2x cubed minus 8. That's 4x cubed plus the negative 2x cubed. That's negative 9x squared plus 1 plus negative 8. So we're looking at 2x cubed from this sum minus 9x squared minus 7. Here we're subtracting. We have 5x squared minus 6x plus 2 minus 4 minus 6x minus 3x squared. That's 5x squared minus 6x plus 2 minus 4 plus 6x plus 3x squared. That's distributing the negative. So 5x squared plus 3x squared is 8x squared. Negative 6x plus 6x is 0. And 2 minus 4 is negative 2. And we go on to the next page. Feel free to pause if you need some more time there. Multiply two polynomials. To multiply two polynomials, multiply each term of the first polynomial by each term of the second polynomial using the distributive property. So to multiply two binomials, use FOIL. FOIL means you can multiply first, outside, inside, last. So here's an example of two polynomials. let me do this, A plus B times C plus D. That'd be A times C is AC, A times D is AD. So that's the first ones, outside ones, inside ones are BC, and the last ones, BPD. So I can do that here. First, x squared times x squared. Outside, x squared times y. Inside, negative 2y times x squared. Last, negative 2y times y. This is x to the fourth plus x squared y minus 2x squared y minus 2y squared. You may notice I changed this to say negative 2x squared y instead of negative 2yx squared. They're the same thing, multiplication is commutative, but I wrote it in alphabetical order there. So it's x to the fourth minus x squared y minus 2y squared. Okay, I'm going to go on to the next one here. Probably fit it in down there. So if I can't FOIL this because I have 3 terms and 2 terms. So it'd be essentially like x times x minus y, do this. Then xy times x minus y. And then y times x minus y. So if I distribute now, it's x times x is x squared. X times negative y is negative xy. Xy times x is x squared y. Xy times negative y is minus xy squared. And then y times x is xy. And y times negative y is negative y squared. So if we simplify that, we have x squared minus xy. So here I have x squared y minus xy squared. Oh, so those don't do anything, but the minus xy and the plus xy, those are going to cancel out. So erase that. We have a plus x squared y minus xy squared minus y squared. And we're going to go on to look at some special product formulas. I'm going to move on here. So special product formulas, we have a minus b times a plus b is a squared minus b squared. We talked about that in the last section. A plus b squared is a squared plus 2ab plus b squared. A minus b squared is a squared minus 2ab plus b squared. The first 3 should be just boom. They're in your memory. You know that, boom. You can do that without thinking. The next 2 you may not have seen before. A plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. And a minus cubed is a cubed minus 3a squared b plus 3ab squared plus b cubed. So some common factoring methods. Now factoring is reversing the process of multiplication in order to find 2 or more expressions whose product is the original expression. So you take something that's been multiplied out, you're going to go back to something times something. Factorable is a polynomial with integer coefficients that can be written as a product of 2 or more polynomials, all of which also have integer coefficients. I can probably get rid of this. It's like saying going from x squared minus y squared to x plus y to x minus y. This is factored. Okay, prime and irreducible would be a polynomial that cannot be factored. We come across those. Completely factored means to write a polynomial as a product of prime polynomials, so that once it's factored you can't go any further. These are prime, they can't go any further. Now the greatest common factor method means factoring out those factors common to all the terms in the expression. This is the least complex of the factoring methods to apply, and the greatest common factor, or GCF, among all the terms is the product of all the factors common to each term. So let's look at example 3. We have, we're going to use the greatest common factoring method to factor the following polynomials: x cubed minus y squared minus x cubed minus y. So this would be, what's common to both of these? Well, from both of them, x cubed minus y is common. So then from here you have x cubed minus y. You might, well, I'm going to go with this. That part minus this part divided by x cubed minus y is just going to be 1. So it's x cubed minus y times x cubed minus y minus 1. If it helps to see this, you might think of this as x cubed minus y times x cubed minus y minus x cubed minus y. So that you see, oh, I can divide that part out of these two. For the next one, what do we have? We have 27x the 7th y plus 9x the 6th y minus 9x the 4th yz. So 9 is a factor of everything. And then we have x to the 4th. And there's a y in everything. So if I take and I divide this by 9x to the 4th times y, the y is going to go, it's a 3. X to the 7th over x to the 4th is going to be x to the 3rd. Dividing this by 9x to the 4th times y, the y is going to go, the 9 is going to go. X to the 6th over x to the 4th is x squared. Dividing this, 9x to the 4th y, the 9's go, x to the 4th y's, what's left is a z. I'm going to go on to the next page. Feel free to pause that. Now we have factoring by grouping method. Factoring a 4-term polynomial. To do this, we arrange the terms so that the first 2 terms have a common factor and the last 2 terms have a common factor. For each pair of terms, use the distributive property to factor out the pair's greatest common factor. If there's now a common binomial factor, factor it out. If there's no common factor in step 3, begin again rearranging the terms differently. And that happens sometimes. Okay, for this first one, we have ax minus 2bx. I'm going to group those together. Minus, now watch this, 2ay minus 4by. So you're probably thinking, why is this a negative? Well, I factored out a negative. A negative times 2ay is negative 2ay. Negative times negative 4by is positive 4by. So when I group these, and there's a negative out here, I've got to change the sign. Now I can factor an x out. I have a minus 2b. And I can factor out of here what? A 2y. And I have a minus 2b. So it's a minus 2b times x minus 2y. The next one, I group them again, x squared plus 3xy plus 3y plus x. Out of the first pair I could pull an x out and I'd have x plus 3y. Out of the second pair I really can't pull anything out. I'll call it a 1 and rearrange the order x plus 3y. So it's x plus 1 times x plus 3y. So I'm going to go down and use the do the factoring special binomials next. So feel free to pause that if you need to. Factoring special binomial method, and the following a and b represent algebraic expressions. X squared, y, whatever. The difference of two squares, a squared minus b squared, is a minus b times a plus b. So just a few pages ago we saw this one equals that. a cubed minus b cubed, the difference of two cubes, is a minus b times a squared plus ab plus b squared. And then the sum of two cubes, a cubed plus b cubed, we didn't have a sum of two squares, we have a sum of two cubes, is a plus b times a squared minus ab plus b squared. So these two we actually didn't see on the previous page. We saw something a little different. I want to point something out. A minus b there, this is a plus b. Now these are all positive, but there's a negative in this one. So there's, out of all this, one negative for a cubed minus b cubed is there. For all this, there's one negative for a cubed plus b cubed, and it's right there. So remember those differences. So a squared plus b squared cannot be factored in the real sense. It says factor the following special binomials. We have 27a to the 9th plus 8b to the 12th. Now 27 is a perfect cube, not a perfect square, as is 8. So I'm going to treat that as 3a cubed plus 2b to the 4th cubed. Now I have a sum of cubes. And if you remember the formula from the previous page, it's going to be 3a cubed plus 2b to the 4th times the first part, 3a cubed gets to be squared, minus 3a cubed times 2b to the 4th, plus 2b to the 4th gets to be squared. So it's 3a cubed plus 2b to the 4th. That's 9a to the 6th minus 6a cubed b to the 4th plus 4b to the 8th. And the next one is 25x squared minus 16y squared. This is a difference of squares. So that's 5x squared minus 4y squared. That's going to be 5x plus 4y times 5x minus 4y. Okay, I'm going to go on here. Factoring trinomials. So factoring trinomials with a leading coefficient of 1. If the trinomial is in the form a or x squared plus bx plus c, we must find two numbers p and q such that p plus q is b and p times q is c. The factor form of x squared plus bx plus c would then be x plus p times x plus q. So essentially, if you take your c, you put it on top, your b, you put it down below in this little x pattern, p plus q must be b, p plus q is b, p times q is c, so it's x plus p times x plus q. So in this first one, we're going to put the 9 on top, that's the constant, the 6 goes down below, that's the coefficient to x. What are two numbers that add to be 6 and multiply to be 9? 3 and 3. So it's x plus 3 times x plus 3, which is x plus 3 squared. For the next one, 6 will go on top, negative 5 goes down below. What two numbers add to be negative 5 and multiply to be positive 6? Well, they add to be a negative, and they multiply to be positive. So if they multiply to be positive, they're either both positive or both negative. Since they add to be negative, they must both be negative. So negative 2 and negative 3, x minus 2 times x minus 3. And the last one here, x squared plus 5x plus 4. What two numbers add to be 5, multiply to be 4? You can go through your factors of 4, things like 1 and 4, 2 and 2, and 1 and 4 works. So that's x plus 1 times x plus 4. going on to the next page, so feel free to pause if you need to pause that. Now we're going to factor trinomials when the leading coefficient is not 1. This is a little more involved. So for the trinomial ax squared plus bx plus c, you're going to multiply the leading coefficient a and your constant c, factor a c into two integers whose sum is b, where m plus n is b and m times n is a times c. If no such factors exist, then the trinomial is irreducible over the integers and it's prime. So rewrite b in the trinomial with the sum found in step 2 and distribute. The resulting polynomial of 4 terms may now be factored by grouping. So we have ax squared plus bx plus c becomes ax squared plus m plus nx plus c. So it's ax squared plus mx plus nx plus c, and you group that and group that. It'll be clear when we do some problems here. So example 7. Factor the following trinomials. So a is 5, b is negative 37, and c is negative 24. A times c is going to be 5 times negative 24, which is negative 120. So we're going to look for factors of negative 120 that add to be negative 37. So negative 40 and 3 works. Negative 40 plus 3 is negative 37. So it's going to be 5a squared minus 40a. Let me just do this. Minus quantity, or should I say plus negative 40 plus 3 times a minus 24. So it's 5a squared minus 40a plus 40a plus 3a minus 24. So out of the first pair, 5a can come out. And what's left is an a minus 8. In the second pair, a 3 can come out. And we'd have an a minus 8. So it's going to be 5a plus 3 times a minus 8. For the second one, our a is 5, our b is 27, and our c is negative 18. 5 times negative 18 is negative 90. So I'm thinking of same type of thing as before. How about negative 30, no, positive 30 times negative 3, or should I say negative 3 times 30. I like to keep, if there's a positive and a negative, put the negative first. So we'd have 5x squared plus negative 3 plus 30 x minus 18. It's 5x squared minus 3x plus 30x minus 18. I'll write it one more time. So this part is going to be grouped, these two and these two. Out of the first pair, we can pull an x, and we have 5x minus 3. Out of the second pair, we could pull out a 6, and we'd have 5x minus 3. And we end up with 5x minus 3 times x plus 6. Okay, I'm going to go on to the next one, so feel free to pause. So factoring expressions containing fractional exponents. Identify the least exponent among the various terms. Factor the variable raised to the least exponent from each of the terms. Factor out any other common factors. Simplify if possible. Okay, Down to our last page of this section. Another long section, 7 pages. Pretty brutal. Okay, factor 2x to the negative 2 plus 3x to the negative 1. So the smaller of the two is actually x to the negative 2. It would be x to the negative 2 times what? 2 plus 3x. Sorry, just x to the negative 2. Negative 2 is the power. There we go. And the last one down here, we have 3z plus 2 to the 5/3 minus 3z plus 2 to the 2/3. You can divide both sides by 3z plus 2 to the 2/3. This becomes 5/3 minus 2/3 is 3/3. This is something divided by itself, so it's 1. So we have 3z plus 2 to the 2/3 times 3z plus 2 minus 1. 3z plus 2 to the 2/3 times 3z plus 1. And that'll be it. That is it for 1.3. So, hope you learned something here, or at least I hope it's a refresher. I hope you already knew this. And I guess that's it for today. Send me your questions. Thank you.